Hi everyone, good morning. So I think I'm audible to every one of you. Okay, so fine guys, so let's start with the session. So in today's session, we are going to talk about some of the statistical concept, and it will be extension of the same classes that we were trying to take in last session. So I think in last class, guys, in terms of statistics, so we have discussed okay, so what is a basic of a statistics, what is a mean, median, mode, standard deviations, and then we were talking about like, okay, fine, so what is estimations, and then we were talking about like what is a GED statistics, and we have seen that okay, fine, so if we are able to find out GED statistics, so in that case maybe we can try to do the estimations, we can try to perform some kind of estimation operation, and based on the estimation operation, so we will be able to find out, or we will be able to understand that okay, so what kind of estimation we should give if we know the historical result, or if we know the historical output. Now, extending to the same lecture, same concept, I would say, data statistics concept. So there is another concept which also comes into a picture. So there is something called as a T statistics. You should know there is something called as a application of a data statistics that you are supposed to know. So in today's class, we will try to explore such things, and let's try to understand that how we can try to correlate each and everything with respect to a hypothesis testing. So hypothesis is a very important concept that you are going to encounter inside a statistics. And to solve this hypothesis, I'll talk about this what is a hypothesis in general, but it's a very important concept, it's a very vital concept, I would say. So whenever we try to do some kind of assumption, some kind of estimations, because when we were trying to do estimation, if you remember, so we have done one thing over there. So we were trying to say that okay, fine, so I'm 90% confident, I'm 99% confident, I'm 95% confident that this is something which is going to happen. This is what we have done when we were talking about a jet statistics, or when we were trying to talk about the estimation one. Now how we were trying to say that okay, fine, so if we are 90% confident, and again, so we are trying to take like a alpha value, right? So all those things we have done in a last class, and I told you that okay, fine, so I will be talking about these things in a upcoming session. So through hypothesis testing, so I will try to discuss, I will try to talk about each and everything. So the major agenda, a major point over here will be a hypothesis, and inside that, so we will try to cover gender statistics, T statistics, chi-square testing, ANOVA testing, and A/B testing. Because whenever you will get some kind of a data, so to compare two set of a data, suppose you have given me some set of a sample. Now whether these two samples are equal, or maybe there is some variances, you will be able to find out in between those samples. Or suppose if I have made some kind of assumptions, whether my assumptions is correct or my assumptions is incorrect. So to perform each and every operation, so first of all, what we try to do is, so we try to perform this kind of a hypothesis, a testing kind of a operations. And again, so inside that, different kind of a test which gets involved. And again, in an interview, as far as this stats interview is concerned, so yes, people do ask some of the direct question, that what is your understanding about ANOVA testing, or what is your understanding about the A/B testing, or what is your understanding about a chi-square testing. Or on top of that, so people will ask you a question that okay, so fine, if I'm giving you two samples, so or if I'm giving you two set of a data, so how you will be able to verify that both the data are equal, or maybe if it is not equal, then what is the variations that is available in between those data. Or maybe if there is a variation, so how you will be able to normalize all of those data. So these are things which will come into a picture. So let's try to understand by using like a hypothesis kind of a testing. Now, so some of you are saying, guys, YouTube link is not available. So I was trying to make this session live on YouTube, but there is some technical problem that we are facing. So it is giving me session timeout issue. So I don't know what, there must be some problem with the connectivity between Zoom and YouTube. So because of that, maybe we are getting this issue, right? So that's the reason. So we are not able to make live. It's just a technical issue. I'm not sure from which side, from YouTube side or from Zoom side. But yeah, so because of that, so we are not able to make this session live on a YouTube. So those who wanted to join, they can join here. So I think I have already sent a notification to every one of you. If your friends and family or someone wanted to join, you can share the same Zoom link. I think it will be fine. And again, so till last class, so we have already uploaded a recordings of the statistics in YouTube itself. And again, this recording will be updated over there. So fine, guys, let's try to understand that what is a hypothesis testing. So in general, so every day, so whenever we try to perform some kind of a task, so most of the time we try to assume something, we try to make some kind of a statement, or maybe we try to make some kind of a assumptions. So if we are trying to make some kind of a claim, or maybe a statement, or maybe a assumptions, so we try to understand, or we try to we try to always keep those things as a fact, unless and until so we are not going to prove that okay, so this fact is not correct, or this statement is not correct. Now what is the meaning of that, right? So what is a meaning of that? So let's try to understand. So suppose there is a company, there is a factory, right? So in a factory, so they try to produce a straw. So in a factory, they're producing a straw. So I think we all know a straw, right? So to have to drink a soft drink, so we always use this straw. So there is a factory which tried to produce this particular straw, I would say, and they are trying to claim that okay, so the radius of this particular straw will always be equal to 0.05 millimeter, something like that they have claimed. So this is the claim that they are trying to make. A radius of this straw will always be equal to 0.05 millimeter, right? So this is a statement which I'm able to get from the factory. Suppose if I have to buy a straw, and I'm always looking for maybe a straw with radius 0.05. If I'm able to get something lesser than 0.05, or maybe greater than 0.05, I would say this is lesser than, this is greater than. So if I'm able to find out, if I'll go to a like this factory, and if I will be able to figure out that okay, any of the straw which is not having a diameter, or which is not having a radius, is equal to 0.05. So in that case, a claim made by this factory is incorrect. They have initially claimed that okay, so all the straw which I used to produce is having a radius is equal to 0.05 millimeter. But so if somehow I'm able to prove this particular fact, so in that case this claim is not correct, I would say. So I can say that this was a statement which is true unless and until I'm not able to prove this statement as a wrong. Everywhere you will be able to find out that same thing happens. Suppose if I'm trying to prepare for some examination, right? So unless and until I'm not able to, maybe I'm saying that okay fine, so this time I will try to achieve a score is equal to 90%, right? So let's suppose unless and until I don't have an idea about a result, unless and until result has not been announced, so till that time my statement will be correct. But after this result will be announced, so based on facts, so anyone can claim that okay fine, so your statement was valid or your statement was invalid. Similar way, so I will assume, or this factory owner will assume that okay, the radius of this particular straw that they are trying to produce will always be equal to a 0.05 millimeter, unless and until I'm not going to prove it that no, radius of this particular straw is not equal to 0.05 millimeter. And again, so if I have to prove this particular fact, so what I have to do, because there is a factory which try to produce a millions of straw into a multiple production line on a daily basis. So for sure, I can't go over there and try to measure each and every straw, which is practically impossible. So maybe I can try to extract a sample. Sample means I'll just try to extract maybe a 10 pieces or maybe a 20 pieces, and by using a vernier caliper, maybe I will try to measure a radius. And even if in a single straw, if I will be able to find out that okay, your radius is not equal to 0.05 millimeter, so in that case I can clearly say that okay, the statement made by this factory is incorrect. To prove it, right? So to prove it, I have to collect a sufficient amount of a sample, and then only I will be able to prove this particular fact. Otherwise there is no chances that I will be able to prove these particular things. In the similar way, so if I have appeared for an examination, same thing will happen, right? So unless and until result is not been announced, so fine, my statement is correct. If I'm saying 90%, 95%, maybe a 99% result, it's correct. But once this result will be announced, so based on the fact, anyone can understand that okay, or anyone will be able to tell me that okay, fine, so my statement was correct or my statement was incorrect. So it's a similar kind of a thing which happens inside a court. So unless and until you are not guilty, you are supposed to be treated as a innocent one. So same thing happens everywhere, I would say. So it's completely fine, not an issue. So even with respect to a data, or even in statistics, so we try to perform a similar kind of a operation that is called as a hypothesis. So in hypothesis, you will be able to find out a two kind of a situation. In a hypothesis, you will be able to get two kind of a situation. So the first kind of a situation is called as a null hypothesis, and it's a very important one. So suppose if anyone is going to make some statement that okay, fine, radius of all this straw is equal to 0.05 millimeter. If someone is saying that okay, fine, so this person is a innocent. If someone is saying that okay, fine, I will be able to get 90% of marks. So basically this is a statement that you are getting from the owner, or maybe this is the statement you are getting in a very first instance. And we always try to treat this particular statement or whatever claim people are trying to make. So we always try to consider this particular claim as a null hypothesis. So there is a term inside the statistics which is called as a null hypothesis. So suppose if I have made a statement that okay, so the diameter or like a radius of this straw will be equal to 0.05 millimeter. So now what is my null hypothesis which I can try to build? So I'm saying that okay, average of, I'm trying to say that okay, average of this entire straw radius will always be equal to, so I can say that mu is equal to 0.05. This is the claim which I'm trying to make as of now, and notation is H0. This is called as a what? It's called as a null hypothesis, I would say. So this is called as a null hypothesis, means your actual statement is treated as a null hypothesis. And notation for any kind of a null hypothesis or any kind of a statement in a very beginning, so any kind of a statement can be considered as a null hypothesis unless and until I'm not able to give a I'm not able to prove that okay, fine, so this null hypothesis is not correct. Now, so as you can see, so notation for this null hypothesis is equal to H0. Now, what is the alternative hypothesis? So suppose if you are going to make a claim that okay, fine, so average radius of each and every straw is equal to 0.05 millimeter. So fine, this statement is justified with a statement. Now, so suppose if I'm going to say that no, average radius of entire straw that we are trying to produce is not equal to 0.05, it could be something else. So that kind of a statement we always try to represent, I would say, by using a notation called as H1. So H0 for null hypothesis, it's just a notation. It's just a notation that you will be able to find out. So which used to call that as a null hypothesis, and H1 is called as a alternate hypothesis. So H1 is called as a alternative hypothesis. Now, what could be my alternate hypothesis? If average of this one is lesser than or greater than in both the side, I can say. So because my claim was, so whatever straw which I'm trying to produce is having a radius is equal to 0.05. Now, So what will be the counter attack for that? So the counter attack or the counter hypothesis or the alternate hypothesis or H1 is nothing but, so if I'm able to find out any of these straw which is lesser than 0.05 or greater than 0.05, I can say that, okay, fine. So that is a alternate hypothesis. Now, at a time, at any given point of a time, so either at any given point of a time, either this null hypothesis will be correct or this alternate hypothesis will be correct. It's not like both of these states will be correct at any point of a time. Now, so in the statistics or even in our real life, what happens is, so sometime we will not be able to prove a actual fact, or sometime we will not be able to prove a original statement, or whatever null hypothesis assumptions that we are going to make. So most of the time you will be able to find out that it's very impossible, it's not possible at all to prove a null hypothesis. Then what we used to do, for example, so let's suppose if I have to prove that there is a oxygen in a air, right? A very simple example. Let's try to correlate these things. So suppose if I have to prove that, okay, fine, so there is a oxygen in a air, right? Now, so maybe like a, if I'm not a chemist, or maybe if I don't know how to do something with the oxygen, or like how to test this oxygen availability in this air or in our environment, so for sure I will not be able to prove it, just like a normal guy, right? So if I'm just trying to work as a statistician over here, and maybe like just as a normal guy, if I'm trying to work, and I will not be able to prove that whether there is oxygen inside the air or not. But we know, somehow we know that, okay, fine, so if we have to burn something, we need oxygen. So we, as a human being, so we always try to consume oxygen. Without oxygen, it's nearly impossible. So it's impossible, it's completely impossible, I would say, to live. So maybe I can stop taking, or maybe I will stop breathing, right? And after some time, so I will feel that, okay, fine, so I'm suffocating, right? So maybe in this way I will be able to prove that, okay, fine, so based on some other kind of a fact, and we will be able to prove that, okay, fine, there is oxygen. I know that, okay, fine, so to burn anything, so we need oxygen. So maybe I will try to burn something. If I'm able to burn something, fine, I will be able to prove that there is a oxygen, right? So most of the time, even in your real life, so it's nearly impossible to prove a null hypothesis. Now here, if you have to prove a null hypothesis in this situation, so how you will be able to find out average of all the straw? So suppose if I'm trying to produce a 10 million straw, right? If I'm trying to produce a 10 million straw over here, for sure you will not be able to measure each and every 10 million straw, and then you will be able to find out the average. This thing is not possible, I would say. So you need a huge workforce for that. Unless and until you don't have a huge workforce, you will not be able to measure a radius of each and every straw that you have, for sure. Now what you will do, so you will try to collect some kind of a sample, and then you will try to test some of the sample of the straw. If you are able to find out even a single straw which is not satisfying this particular condition, you can claim that this statement is incorrect and this statement is correct. So sometime proving something is much, I would say, harder, or like a much harder than like disapproving something. And this is the same thing that we used to follow inside a hypothesis testing. So again, so suppose if I have given you a data, right? Now if I'm asking you that, okay, fine, so this is the data set that we have. Now you have to validate a data, that whether this data set is fit for by maybe a machine learning model or not. Or suppose if I have given you two set of a data, if I'll ask you, okay, fine, tell me that both of this sample belongs to a same subset of the data or not, or both the sample are having some kind of a correlation in between those things or not. So it's like a very, like a almost impossible to match each and every numbers, each and every data set which is available. So if somehow I want, or maybe I will be able to get some kind of a mechanism by which I will be able to prove that no, so there is some similarity or there is some checks. So in that case, I can say that, okay, fine, there is like some similarity between the data, If I will not be able to prove, I can say that no, there is no similarity. So sometime disapproving something is better than approving something, or I can say sometime, so finding out alternative hypothesis is easier than a null hypothesis. So here in this case, if I'm trying to like approve this particular fact, so for sure it will always be easier for me to check or to establish a alternative hypothesis and then test it. So if this alternative hypothesis is correct, so in that case I will reject a null hypothesis. If I will not be able to prove this alternative hypothesis, if I will not be able to find out even a single straw which is not having a radius is equal to 0.05, in that case I will claim that my null hypothesis or whatever claim that factory owner has made is correct. So this is what happens in case of a null or in case of a alternative hypothesis. So fine, it's not a problem. So again, many people, so suppose you must have seen advertisement. So people used to say, or maybe there is a soap company, so they always try to claim that its product kills on an average 90%, 99% of germs, right? This is what every product companies, every soap manufacturer company used to claim. Now, so if we have to claim something, so what will be as like if we have to prove or disapprove something, so in that case our simple alternate null hypothesis will be, so average is equal to 99%. So they are saying that okay fine, so on an average my soap used to kill 99% of the germs. Now, so what is the alternative hypothesis? So if mu is not equal to 99, so in that case I can say that okay fine, so my null hypothesis is incorrect and this one is correct. If this one is incorrect, if I'm not able to prove it, then automatically this null hypothesis will be correct. So I'm not supposed to test each and every scenario. I'll try to disapprove something. If I'm able to disapprove something, it's completely fine. If I'm not able to disapprove something, in that case whatever statement that people have made is correct. This is what we used to study in case of a hypothesis. And I would say like a statistics is mostly about a hypothesis testing itself. So whether we are going to talk about like a Z statistics or T statistics or maybe a chi-square statistics or maybe a ANOVA statistics, everywhere you are going to encounter a similar kind of a thing. Now inside this statistics, so you will be able to find out another factors as well. So there is something called as a, so whenever we have to test our null hypothesis, which is our original statement, so we try to perform one tail test and we try to perform a two tail test, and that depends, I would say. And we'll try to understand that how it is correlated with previous things that we have discussed so far so forth. So we try to perform a one tail test and we try to perform a two tail test. Okay, so what we used to do is, so always try to do a one tail test or we always try to do a two tail test. Now, what is a meaning of one tail test and what is a meaning of a two tail test? Because even in just statistics, T statistics, chi-square, ANOVA or A/B testing, so you will be able to perform these kind of a testing, one tail and two tail. It's again a very simple concept, but many people gets confused. So let's try to talk about like what is a meaning of a one tail test and what is a meaning of a two tail test. So if the alternate hypothesis gives the alternate in both sides, if you have assumed some, if you have given some statement and that statement is a null hypothesis and you're trying to build a alternate of that, right? So alternate of that, and if the alternate hypothesis gives alternate in both the direction, lesser than as well as into a greater than, then I would say these kind of a hypothesis is called as a two tail test. So for example, let's try to understand these particular things. So people said that okay fine, so radius of this straw will be equal to, or average of this radius of this straw will be equal to 0.05 millimeter. This is the null hypothesis which I have assumed. Now on top of that, so whenever I'm trying to build alternate hypothesis, it could possible that in my measurement, so some of the straw can be can have a lesser than 0.05 of the radius, or can have a greater than 0.05 of the radius. Possible. So some of the data can fall in this region, some of the data can fall in this region. That is clearly possible, I would say, in this particular case. So whenever I'm trying to check, so maybe I can try to check in this region as well as I will try to check in this particular region, and then I will try to find out the similarity, right? So here we are trying to take, or we are trying to test from both the end, I would say, from the like a left hand side, as well as we are trying to test on a right hand side. So we are trying to check that, okay, fine, so is it lesser than 0.05 or is it greater than 0.05? In both the cases, my alternate hypothesis will be true and my null hypothesis will be false in both the cases. So, but here, to prove or to disapprove my null hypothesis, so I'm trying to test in both the direction. I'm trying to test a lesser than scenario as well as I'm trying to test a greater than scenario. And this kind of a test is called as a two-tail test. Even people ask you a question that, okay, fine, so if you are going to build some kind of hypothesis, so what will be the kind of a test you are going to perform? So whether it's a one-tail test or whether it's a two-tail test that you are going to perform. And again, it's a very simple thing. So you can give a very simple answer for that, I would say. So fine. So again, if suppose, so someone is trying to claim that, okay, so a straw will be, so a straw radius will be on an average greater than or equal to 0.05. If someone has already made a claim that, okay, fine, so this will always be greater than equal to, on an average, it will be greater than or equal to 0.05. So fine. So in this case, if someone has built this kind of a like a hypothesis, null hypothesis, so maybe what I can do is, it should be this one, yeah, notation wise. So in this case, maybe I can try to perform, or even in this case itself. So even in this case itself, so if I'm trying to perform, I would say, so even in this case, if I'm trying to perform, or I'm trying to consider just this situation or only this situation, and based on that, if I'm trying to testify my result, so I can say that, okay, fine, so this kind of a test is called as a one-tail test. If I'm just trying to check at only one end, so in that case, okay, fine, so it's a one-tail test. So it depends upon the situation, depends upon the scenario. So sometimes we try to perform this kind of a things in one tail or in a two tail. So guys, am I audible to everyone? I think I'm audible to everyone, right? Yes, yeah, I'm audible to everyone. Okay, fine, guys. Yeah. Okay. So, okay, fine, guys. I think I'm audible to everyone. Some of you were like pinging me that I'm not audible. Maybe there is some issue with your system. So just try to check that out. Okay. So fine, guys. It's not like a so fine. We were talking about the hypothesis, and we have discussed that. Fine. So hypothesis. What is a hypothesis? First of all, what is a null hypothesis? What is a alternate one? And again, it's applicable in every like a instance of our life, I would say. And we have seen that, okay, fine, so what is the definition of one tail test, what is the definition of a two tail test? These are the basic concept, I would say. Now on top of that, so there is something called as a critical reason. So these are the words, these are the terms that you are supposed to know at any point of a time. So there is a term called as critical reason. Now what is a critical reason? So let's try to understand it. So I think last time we talked about alpha value, right? So out of nowhere we have taken z of alpha by 2. Now how we have taken z of alpha by 2, what is alpha over there? So let's try to understand each and everything in detail in today's class. So whenever you are trying to build a hypothesis, so for sure you always try to consider that, okay, so in which range my null hypothesis is going to fail, or in which range, if my data is going to come, then my alternate hypothesis will be correct or my alternate hypothesis will be incorrect. And based on that, so we try to either approve a null hypothesis or disapprove a null hypothesis. So here, to approve or to disapprove, this critical reason always plays a vital role. Now, what is this critical reason? So a critical reason is a kind of a reason, I would say, in for with respect to your data set, which calculates a value, maybe a kind of a value which we reject inside a null hypothesis. So what is the meaning of that? I'm trying to say that a critical reason is a reason into a data set, I would say, in which we calculate a value which lies. So if in which we try to calculate always some kind of a like a mathematical operation we try to do, and if I'm able to prove that, okay, fine, so my value lies in this particular reason, then in that case, we try to reject a null hypothesis. So based on the previous example itself, let's try to understand it. So I said that, okay, fine, so average straw diameter or radius will be 0.05. Now my alternative was, so if it is lesser than 0.05 or greater than 0.05. So I can say that, okay, fine. So if my data is lying here, or if my data lies in this particular place or in this particular place, so in that case, I can try to reject this null hypothesis. If my data is not falling, if my data set is not falling, or if my sample is not falling in this region or in this region, so in that case, for sure, my null will be correct, right? So I can say that these regions are a critical region for us, I would say. So these regions are what? These regions are critical region for us. So if any single data set or any single instances or even a single sample lies in between this region, so I can clearly say that fine. So my null hypothesis is incorrect, or I can reject a null hypothesis. So a rejection, I would say, a rejection boundary or a point where we can reject a null hypothesis. So you can consider that as a critical reason. So yes, these reasons are very critical for us. If some data falls in between these two regions, in this region or in this region, my statement, my original statement will be incorrect. It will go for the toss, I would say. So fine. This is something that we always try to understand. So let's suppose if I'm trying to buy a, or maybe if I'm trying to rent an apartment, right? So let's try to consider another scenario. So suppose if I'm trying to rent an apartment, and my budget is, I would say, 15,000 to rent an apartment, right? So I'm looking for an apartment actually, and my budget is, let's suppose, 15,000. Now, so I can't spend more than 15,000, let's suppose, right? So for sure, what you will do, so you will go to some website, or maybe you will try to connect with some person, right? And then you will ask, maybe with a broker, you will try to connect, and then you will ask that, okay, fine, so I'm looking for a house. Now, so your broker, or maybe in a website, so you will be able to find a place where you can try to mention your range, or maybe you can try to filter out. You can try to filter out that, okay, fine, so what is an apartment that we are able to get in between this particular range, right? So if, let's suppose, so let's suppose if I'm able to build a null hypothesis over here, that I will rent the apartment. So I will rent the apartment, and what will be my alternate hypothesis in this particular place? I won't. Okay, so either this one will be correct or either this one will be correct. Both of these two statements can't be correct at the same point of a time, you can say. So either you will be able to rent an apartment or you will not be able to rent an apartment. Simple, right? And in which condition you will be able to rent an apartment? So basically, at any point of a time, if the rent of your apartment is 15,000 or lesser than 15,000, so for sure you will be able to rent a apartment. But at any point of a time, if rent of apartment is more than 15,000, so for sure you will not be able to rent. Now what you will do? you will go to a website, you will try to search, for a house, you will try to search for a new house over there. Now, so you will be able to get a range basically. So let's suppose you are able to get a range maybe in between 7,000 to 30,000. This is the range that you are able to get in terms of a house. Now you can clearly say that whatever price that we are able to get, which is greater than 15,000, is called as my critical reason. So again, this is just another definition of a critical region which I'm trying to give. So here, what will be my critical region? So my critical region will be any value which is greater than 15,000 or any kind of a range that we are able to see which falls or which is greater than 15,000. So this is the this is the range in which I have selected my data, right? 7,000, 30,000. It is trying to show me an apartment, and whatever apartment that we are able to get which is more than 15,000, so that apartment or those apartments are my critical reason, I would say. So those a price slab or those like a rent slab is basically a critical reason for me. So it's very simple. So critical reason is a kind of a reason or kind of a space where you always try to reject your null hypothesis. You always try to reject your original statement. So if let's suppose if you are able to find out some house with the price, maybe with the rent, I would say of a 16,000. So in that case, your H0 or your null hypothesis will be incorrect. So basically you can say that your alternate hypothesis will be correct, saying that I won't rent an apartment. You will not be able to rent an apartment. So if the price or if the price that we have decided is greater than 15,000. So from 15,000 to 30,000 in this case will be my critical reason. So whenever we try to perform some kind of a testing, so we always try to identify or we always try to define, I would say, a critical reason. So here, if I will talk about a critical reason, and if I'll ask you a question that whether this particular test is one-tailed test or this particular test is two-tailed test, right? If I'll ask you a question that, okay, so this particular test, if I have to test this null hypothesis, if I have to test this alternate hypothesis, so what kind of a test you are supposed to perform? Is it a one-tail or is it a two-tail? So what do you have to do? So my null hypothesis says that I will be able to rent an apartment. And what is the condition for that? My budget is 15,000. So for sure, if I will be able to get anything lesser than equal to 15,000, so for sure I can say that my null hypothesis is correct. My null is correct. If I'll talk about alternate, so in this case, what will happen? So in this case, I can claim that, okay, fine. So anything which is greater than 15K will be a alternate hypothesis. So I can say that here we just have to test only in one direction. We are not supposed to test in both the direction because my budget is already defined. So I can say that in this situation suits to a one-tail test. So you're just supposed to test in one direction. How we are going to test it, we'll try to figure out. We'll try to figure out in a later stage. We have to solve many more problems, I would say. But as of now, if I'm talking about this alternative hypothesis or maybe a critical reason or maybe a one-tail test or maybe a two-tail test. So here in this situation, in this scenario, so I have to test these things only in one direction. I'm not supposed to test these things in both the directions, I would say. So this is, first of all, this is a one-tail test. If someone will ask you that what is a critical reason for this data, critical reason of this data is any data which is greater than 15,000 to 30,000. That is a critical reason for me, I would say. So critical reason, so for different kind of a situation, for a different kind of a scenario, so critical reason may lies on one-tail test, or it can possible that it will lies on a two-tail test. Here, as of now, I have a critical reason, but it's available only in one direction. I would say greater than 15,000. So only in that direction, these things are available. Okay, so fine. So that is basically my critical reason that you will be able to find out. So critical region can exist in both the sides, or it can exist like in my previous example. So when I was talking about the straw, so this example which I have written, another example, so here my critical region can lie in both the direction. But if I will talk about like this particular cases, so in that case my critical region is available in only one side. So it can be one tail, it can be two tail, and based on that, so we are supposed to perform the testing operation. So I would say that okay, so critical region is nothing but it's basically a predefined area. So in other words, you will be able to see that, okay, so critical region is nothing but it's basically a predefined area corresponding to the cutoff value of the probability distribution curve. I would say. So just okay, fine guys. So basically, I was talking about like what is a critical region. So we said that okay, fine. So critical region can exist into one side or maybe two sides. So if it exists into a two sides, so in that case, you will have to do a two tail test. And if it exists inside in a one direction, so you will have to do just a one side test. This is what we used to perform in terms of a critical region. So let's try to understand all of those things in a single shot or by looking into some kind of a example. So let's try to understand it. So before that, so there is something, there is a term called as a critical value that you are supposed to know. So fine, now we are able to understand a region for sure. Now critical values are nothing but it's a kind of a values separating the values that doesn't support, I would say, or basically in other word I can say that, so critical values are basically values separating the such kind of a values which supports or reject a null hypothesis, and that is been calculated based on the alpha. Now what is a meaning of that? So I think in last class, so we were talking about z of alpha by 2. And what is our meaning of this one? We said that okay fine, so this is a critical value. Based on that, so we were trying to find out the confidence. Now what is the meaning of all such things that we have done in last class? So let's try to understand one by one with respect to some kind of a example. So suppose if I have defined my critical reason, if I have defined my critical reason for some of the cases, and a case of a straw where mu should always be equal to 0.05 millimeter, and my alternate is nothing but it can be greater than or it can be a lesser than, I would say. So let's suppose if my data set is normally distributed, so in that case for sure it is going to build this kind of a curve, I would say. So this is nothing but, I think we already like we have gone through this kind of a curve, which is nothing but a normal distribution. So let's suppose if I'm trying to perform this kind of operations, and if any of my values of the straw, so let's suppose like a value of the straw is normally distributed. So if any of a value of our straw lies in this region, I would say, which is nothing but a greater than 0.05 and lesser than 0.05, so I can say that okay, so this is my critical reason, and this is my critical reason. So if any values of a x, any values of a input which is below this one and above this one, so I can try to say that, okay, fine. So we have a critical reason. So whenever we try to consider a critical reason in both the sides, and let's suppose I was talking about a critical values, which is nothing but it's a notation. It's a notation of for the critical reason, I would say. So which is called as a alpha, which is called as a alpha. So if we are trying to perform a two-tailed test, I would say, if I'm trying to perform a two-tailed test, so in that case, you can divide this alpha, and here we are supposed to assume, or we are supposed to take alpha by 2 in both the sides as a critical value. Suppose if I'm giving you that, okay, fine, so critical value is like greater than 0.5 or lesser than 0.5, or if I'm trying to say that, okay, fine, so like I'm 90% confident that, okay, so this will be correct. Suppose if I've said that I'm 90% confident that, okay, fine, so this will be correct. But there is a 10%. There is a 10%, and I can try to consider that, okay, fine. So I can say that, okay, fine. So there is a 10%. I'm confident that, okay, fine. This will not be equal to this much. So in this case, I can say that this 10% is nothing but a critical reason. Now, so in terms of, or I can say this is called as a alpha. Now, whenever we are trying to perform a two-tailed test, so we will try to consider, okay, fine. So 5% of this test we are supposed to do here, and 5% of this test we are supposed to do in this particular case. In both our side, it's not like we are supposed to do a 10% of test in both the sides. So I'm supposed to test 5% and 5% because it's a two-tailed test. So in case of a two-tailed test at any point of a time, so we always try to consider alpha by 2 values instead of considering simple alpha values. And this is how we try to define our critical values in a two-tailed test at any point of a time. In double test, I would say. Now, so if we are just testing for a one side, so for sure in that case, my alpha value will be equal to 10%. If I'm going to claim that, okay, fine, so I'm 90% confident that, okay, so this is going to happen. And I'm 10% not confident that, okay, fine, so this will be like a true, or alternate will be true. So this confidence that we are trying to showcase, and based on this confidence, I can assume that this will be my critical value for the particular critical reason. And depends like I'm trying to perform a two-tailed test, or if I'm trying to perform a one-tailed test. Again, inside a one-tailed test, so sometime we always try to test it only in our right hand side direction. So if there is some value which lies in between this area, so I can say that it's a right hand test. And if there is some values which will lie in this region, suppose if we have considered lesser than or something like that, so this is called as a left hand test, I would say. So it depends upon the situation, depends upon the scenario. So we try to perform a left hand or we try to perform a right hand. Last example which I have given you, where room rent was 15,000. So till 15,000 I will be able to like I will be able to afford. So any values lesser than 15,000, yes, I will be able to afford lesser than or equal to 15,000. But if I'll try to consider greater than or equal to a 15,000, so for sure I will not be able to afford. And I can clearly say that in that situation, so we have to test it only for the right hand side. So that will be basically a right hand test in this particular situation or in this particular scenario. So it depends, I would say, guys, right? So it always depends, like we are going to perform a one-tailed test or two-tailed test. If it is a one-tailed test, then whether it will be like a right-hand test or whether it will be a left-hand test at any point of a time. That is completely fine. So we will try to solve many more examples based on this particular alpha value, and many different kind of a situation, in a many different kind of a scenario. Now, so let's try to understand that in hypothesis testing. So what is in hypothesis testing? So what is the actual meaning of a alpha? So let's try to understand it, which is very much important, because as of now we have said that, okay, fine, so alpha is nothing but it's a critical value. Critical value means, so wherever my failure cases is going to arise, so that is called as a, so that particular reason I would say is called as a alpha. or I can say it's a alpha value, or it's a critical reason. This is what we have claimed. This is what we have studied so far, so forth in this particular situation. Now, so let's try to understand that what is the meaning of the alpha in case of a hypothesis. And the chart which I'm going to talk about, the chart that we are going to discuss over here, I think most of you have seen this kind of a chart some point of a time. But let's try to understand it in a proper way this time. So let's suppose, and based on that, so we will try to understand or establish relations for a alpha. So let's suppose if I'm trying to make some kind of a decision. So if I'm trying to make some kind of a decision, if I'm trying to make, so it could possible that this decision will be true. True means what? So true means nothing but, so whatever assumptions that we have made. So if that assumption is going to happen, so for sure in that case, it will be true. If the assumptions that I have made, if it is not going to happen, so in that case, it will be equal to false. As simple as that. Okay. So fine. Let's try to understand it over here. So if assumption, now what is the meaning of assumptions? It's nothing but our null hypothesis. Okay. So it could possible, so whatever decision that we are going to make, so it could possible that H0 will be true. TRUE. Okay. Now it could possible that H0 will be false. So this is the only situation which is possible. Either my null hypothesis will be true, or either my alternate hypothesis will be true. In that case, null hypothesis will be false. So fine, I'm just trying to write this down in terms of a null hypothesis itself. So either my decision will be correct or my decision will be incorrect. This is something based on my assumptions, I would say. So this is something that you are going to face, or this is something which is going to happen. So suppose if I'm trying to make some decision, right? So while making this kind of a decision, so either I can try to accept a null hypothesis, possible. So suppose if I have made a statement, that, okay, so I will score 90%, right? I will score exact 90%. So that is my so that is my null hypothesis. Now what could be my alternate hypothesis? So if I'm able to get lesser than or greater than, so in that case, that will be a alternate hypothesis. And in that case, we can try to reject our null hypothesis. As simple as that. So in any situation, either you are going to accept a null hypothesis or you are going to reject a null hypothesis. These are two situations which is possible, I would say. So fine, possible that you are going to reject null hypothesis, or maybe you can say that do not reject or maybe accept null hypothesis. These are the two situations which is possible. So you have built an hypothesis, right? You have made a decision. Now your decision can be correct, your decision can be incorrect. Now, so if I'll talk about like a testing, so it could possible that you can either reject a decision that you have made, or you can accept a decision that you have made. These are the situations which is possible. Now, so let's suppose if something is already correct, but if you are trying to reject it, so suppose something is already correct and if you're trying to reject it, for example, so in an Indian Penal Code, IPC, right? So Indian Penal Code always says that unless and until you are not able to prove a crime of the person, so that person is not a culprit. That person is basically what? It's a innocent person. This is what we always try to say, like here, right? From any kind of a code. So unless and until that person is not proven as a guilty, that person is innocent, I would say. So fine. So let's suppose, just try to correlate with this particular hypothesis testing. So let's suppose if person is innocent, right? That is my null hypothesis. That person is innocent. And here you can say that person is not innocent. Okay. So fine, if person is innocent, if person is innocent means my null hypothesis is correct. And if you are trying to, if you are trying to prove that no person is guilty, means you are trying to reject a null hypothesis, right? You are trying to reject a null hypothesis. My assumption was person is innocent, and indeed person is innocent. Let's suppose person is innocent, but somehow you are able to prove that no, that person is not innocent, person is guilty. So you can say that you have made a mistake in this particular place. You can clearly say that no, I have made a mistake, person was not, person was innocent, and then I have proven that no, a person, I have rejected this null hypothesis, that okay, so somehow based on some kind of facts, figures and tests, so we have rejected the null hypothesis. So in that case I can say that it's basically a problem, and this is called as a type 1 error, I would say. So this is called as a type 1 error, where we reject a true null hypothesis. Means, so person was innocent, my hypothesis, null hypothesis was true, but still somehow I have rejected it. And in this way, for sure, I'm going to make a mistake. Person was innocent, but I have proven that no, person is guilty. Let's suppose if person is not innocent, right? So H0 false means person is not innocent. Person is not innocent. And you have proven, or you have rejected the null hypothesis, means you have proven that yes, person is not innocent. Rejected means person is not innocent, right? So you have proven that yes, person is guilty. So I can say that this decision is a correct decision. So person was not innocent means person have done some crime, and you have proven that okay, fine, so this person is guilty. So in that case you have made a correct decision in this particular reason. Now here what I can say, so here I can say that a person was innocent and you have accepted it, means even you are saying, or you have proven that okay, fine, person is innocent. So even over here I can claim that I have made a correct decision, because person was innocent, I have proven that yes, person was innocent, and in this case I can try to accept a null hypothesis. Now so here person was not innocent, right? And but I have accepted a null hypothesis, means I have proven that no, person is innocent. So person was not innocent and I have proven that person is innocent, basically. So person has done some crime, but somehow I have proven that no, person has not done any kind of a crime. So again in that case I can say that I have done some kind of a mistake, I have created a blunder over here, and this is called as a type 2 error. So in your entire machine learning class, you are going to utilize this particular chart, I would say, with respect to our confusion metrics and with respect to many other concepts as well. We always try to apply this thing. These things is very much important, I would say, to find out an accuracy of a model. So because for whatever model that we used to build inside a machine learning, so for sure, unless and until you are not having an idea about the confusion matrices, so you will not be able to test or testify those things for the classification problem. For the classification problem I'm talking about. So again, there is other way as well to testify those things, but still, as of now, let's try to understand for the classification problem. So we always try to build a confusion matrix. So this, in another way, I would say this same thing is called as a confusion matrix. So confusion matrix is a term, I can say. So here we always try to build an hypothesis, and then whatever probability is possible, so we always try to establish a facts and figures with respect to that. So it's completely fine. This is a confusion matrix that I have. So here in about a very top, so I have written my null and alternate, and then whether I'm rejecting a null or whether I'm accepting a null, means after testing, I would say. So if person is innocent, if person is innocent and you have proven that no, person is not innocent, basically it's a type 1 kind of error. In that case, we are trying to reject what? We are trying to reject a true null hypothesis. So my hypothesis was correct, but I'm trying to reject it. I'm trying to reject it. So that is a type 1 error. I would say that type 1 error is a severe error as compared to a type 2 error. So when your hypothesis is correct, but still you are trying to reject it when person is innocent, and then still you are trying to reject it. So in that case, I can say that this kind of a situation is more severe as compared to a type 2 error over here. Again, based on the statement, it is going to change. I'm not saying that it is going to be a same for all the time. So in many books, you will be able to find out the same kind of a thing. So based on the situation, so it is going to change, I would say. So here we have, so if person is like a not innocent, but you have proven that innocent, it's completely fine. It's less severe error as compared to this one, because even our Indian penal code used to say, even our constitution used to say that we can free maybe 100 culprits, but we are not supposed to imprison even a single innocent person, right? It's completely fine if we are not able to punish maybe a culprit, but we are not supposed to imprison, I would say, even a single innocent person unnecessarily. This is what our constitution says. So here in this situation, I'm talking about just a situation, it's a contextual thing. So here in this situation, I can say that, okay, fine. So this is a type 2 kind of a error. And again, like I told you, so this thing is heavily used in our like machine learning, like a model validations. So whenever we have to validate a model, that okay, fine. So how and what is the performance of our model is. So type 1 error and type 2 error. So the other name of this type 1 error is, I would say, false positive. And if I'll talk about a type 2 error, so in other way, it's called as a false positive. Means whatever is the false, so yeah, so we are trying to consider that as a positive. And whatever is a false, so yes, we are trying to consider that as a negative. So this is just the other name. So many people just get confused that, okay, fine. So I used to say that, okay, fine. So the false positive is very high. So false positive is very high means what? So false positive is very high simply means that you are able to get a type 1 error. And that means that, so your null was correct, your null hypothesis was correct, but you have rejected it. You have proven somehow that no, null hypothesis is not correct. And that is called as a false positive. If I'll talk about type 2 error, so it's nothing but it's a false negative, and it's basically a situation, it's basically a scenario where your null was not correct, your alternate was correct, but somehow you have proven that no, null is correct. Null was not correct, but you have proven that null is correct. So that kind of a thing is called as a type 2 error, I would say. And here, if I will try to talk about alpha, which was nothing but a critical value, I have referenced as a critical value in our previous slide. So here I can clearly say that alpha is nothing but a probability of rejecting. So alpha is nothing but a probability of, I would say, rejecting null hypothesis when H0 is true. So this is called as a critical value. So alpha in this particular term, you can try to assign that probability of P is nothing but, so I have denoted as a probability. So probability of rejecting H0 when H0 is true. So means type 1, I would say. So alpha is nothing but it's a critical value, or the reason where you will be able to reject a null hypothesis even if it is correct. Now, so there is, so basically like if I'll talk about another term, so the another term is called as a beta. So beta is nothing but, so basically if I'll talk about like this alpha one, so probability of committing this type 1 error, or I can say like a false positive error, is always equal to a significance label, always equal to a significance label, or I can say a size of the critical region, which is nothing but alpha. in this particular case. Now there is another term that you will be able to find out, and that term is called as a beta. Now what is beta? So beta is nothing but its probability of committing a type 2 kind of a error. That is called as a beta. So that is called as a beta, and in other word, beta is also called as a power of testing. So power of testing means how many data set or how many events that you have encountered which was false, but you have proven that as a true. That is called as a type 2 error. You can clearly see these things in our confusion matrices. Clearly see that, okay, fine, type 2 error is what? So type 2 error is nothing but it's basically accepting a null hypothesis. So basically like accepting a null hypothesis when already it's a false. That is called as a type 2 error. So beta is nothing but it's a probability of. So what is the probability that there can be a false negative? Now what is false negative? False negative means, so your actual data, or maybe I can say that false negative is nothing but, so your actual say that, okay, fine, so you are not innocent, but you are trying to prove that, okay, fine, no, this person is innocent. This person is innocent, right? So again, in many such kind of events has already happened where person was not innocent, but they get a bail, right? Or they didn't the court was not able to punish them at all. So we all are aware about that, basically. So this beta is nothing but a probability of committing a type 2 error, and in other words, it is called as a power of testing, or in terms of probability, if I'll try to tell you that it's nothing but not rejecting null hypothesis when null is false, means H1 is true. Null is false means H1 is true. So this is also called as, in other way, this is also called as a power of test. So if I'll ask that, okay, fine, so tell me that what is the power of testing that you have done on top of the data set? So in that case, you will try to give me a beta value, probability of not rejecting when H0 is false, when null hypothesis is false, I would say. And suppose if I'm asking you that, okay, fine, so tell me what is your critical values. So in that case, you will always talk about a alpha. So fine, guys, not an issue. So these are just a term that you are supposed to know, I would say. Now there is something called as a label of significance. So what we have discussed so far, so forth. So we have started with the hypothesis, and then inside that, so we have seen that fine. So these are some terms that we are supposed to understand. So first of all, we have seen that, okay, fine. So what is like null hypothesis, then what is the alternate hypothesis, and then what is a critical reason, what is a one-tailed test, what is a two-tailed test, what is a right-hand test, what is a left-hand test, and then we are talking about actually like confusion matrices. So in which scenario we are supposed to accept something, in which situation we are supposed to reject something. What is a meaning of an alpha? Because always many of you will get confused with the alpha definition of an alpha. It always confuses. It's completely fine. And beta, I think we barely use this beta, but still, if you are trying to do some kind of a statistical analysis on top of your regression model or something, it always gives you a value for the beta, and beta is always considered as a power of testing. So whatever test that you are going to consider on a particular data set. Now there is something, so we talked about like alpha. Alpha is like a critical value. The other term for the alpha you will be able to use is as a label of significance. That is also called as a alpha, I would say. So it's nothing but, what is alpha? So alpha is nothing but probability of a type 1 error. So whenever I'll ask you that, okay, fine, so you have done some kind of a test. Now give me a label of significance. So label of significance alpha is nothing but probability of getting a type 1 error. Simple. Beta is nothing but probability of getting, what is the probability that you will be able to get a type 2 error? What is a probability that you will be able to get a type 1 error, right? So if so in both the cases, whether I'm talking about a type 1 error or whether I'm talking about a type 2 error, in both the cases we have made an incorrect decision, right? So again, this will be my critical values, and then so it always alpha always try to give you a probability of committing a type 1 kind of a error, which is a severe one. Type 2 is completely fine, it's not an issue, major issue, but yeah, if I'll talk about the type 1 issue, so yes, it's a simplest one, I would say. And it's also like equal to a size of the critical region, because alpha is nothing but it's critical values or the critical region, both are the same. Now, so whenever we are trying to perform some kind of an experiment, so we always try to set that our confidence level. I'm 95% confident, I'm 99% confident, or maybe I'm 90% confident. This is what we have done. So when we were trying to find out, or we were trying to do experiments in the last class, so we have done a similar kind of operation. So we have seen that we were trying to set that, okay, so whether my claim is going to be like 90% correct or 95% correct, or maybe 99% correct. We always try to set these kind of things, I would say. Now, so we always try to set our confidence level that, okay, fine, so this is this much correct or that much correct or whatever. We always try to set, or we always try to set this particular labels, I would say. So this is completely fine. Now, so what is a significance label? Because we have set the confidence. What is a significance label? I would say. So if I'll ask you, significance label in this one will be 5%, because what is a critical reason? What is a critical value? 5% is a critical value over here. Now here 1%, here 10%. So 10% is basically alpha, 1% is basically alpha, and 5% is basically alpha, or I can say a critical reason. So if somehow, so suppose if I'm saying that I'm 95% confident that I will be able to clear this exam, right? So in that case, your critical reason or your label of significance or your alpha or your critical value or probability of occurrence of your type 1 error means you have claimed that no, I will be able to get, I will be able to pass this exam. I'm 95% confident. But what is a label where you will be not able to clear the exam? So in that case, there is a 5% reason, a 5% chances that you will not be able to clear. There is a 5% probability that you will not be able to clear. You have claimed that no, I will be able to clear, and with confidence 95%. But still there is a 5% chance that you, whatever you have assumed that your null hypothesis is what? Null hypothesis is clear exam. Now, what is your alternate hypothesis? Not clear exam, basically. So this is your null hypothesis and this is your alternate hypothesis. So your null hypothesis is supported by 95%. Your alternate is supported by 5%. So 5% is what? Basically, it's a critical reason or critical value or alpha or level of significance for you. So if you are going to perform some kind of a test, and if your probability is coming inside this 5%, so in that case, you will be able to reject a null hypothesis and you will be able to accept an alternate hypothesis in any situation. This is what happens. So we always try to find out a critical value or critical reason, or we always try to justify, or we always try to find out, or we always try to take a label of significance, which is nothing but an alpha value. So even last time when we were trying to perform an experiment, when we were trying to find out that, okay, so what is estimation for this particular product or this particular inventory? So I think we have solved an estimation problem in our last class, and there we were trying to take a label of significance that, okay, fine, so maybe I'm 90% confident, or maybe I'm like a 99% confident, or maybe like I'm like a 90% confident. And based on that, so we were trying to find out like, okay, so if I'm 90% confident, that what will be the reason, what will be the like a entire reason or entire like a scale on which my data will be stretched. Or we try to find out that, okay, fine, so what will be the reason, or maybe on a 90%, 99%, or maybe onto a 95%. So this 10%, 1% and 5% that we used to consider, so that is nothing but a label of significance, or alpha by 2, or alpha, I would say. And alpha is nothing but it's a probability of occurrence of what? A type 1 error. It's just a probability. It tries to signifies a probability. So what is the probability that your null hypothesis is going to be incorrect? 5% in this case, 95% case. In 99% case, what is a probability that your null hypothesis is going to be wrong? There is only 1% probability. So whatever area which will come inside the 1%, so that is a final probability that I will be able to give. So as simple as that. So it's completely fine. Now I think we know like what is a meaning of a label of a significance. Now, so whenever we try to do a hypothesis testing, because in every statistical problem with every statistical data, so we always try to perform a hypothesis testing. So whenever you are trying to perform those kind of a thing, so there are some prerequisites that we have to fulfill. Unless and until we are not going to fulfill all of those prerequisites, you will not be able to solve a hypothesis problem or hypothesis testing problem, or you will not be able to test data maybe. So first of all, what you have to do is, so the first step will be try to build a null hypothesis and alternate hypothesis. So first of all, whenever I'm trying to accept some decision or whenever I'm trying to reject some decision, so I have to make sure that I have to build a null hypothesis as well as I have to build a alternate hypothesis. That's the first thing that you will have to do. Now on top of that, so second thing that you have to do is, so you have to decide that, okay, so what will be a label of significance, or I would say, so you have to decide that is what is a value of the alpha, whether it's a 5% or whether it's a 1% or whether it's a 10% or whether it's a 20% on which you are going to reject basically. So the first one is decide the hypothesis. This is what we have done. So I was assumed last time that, okay, fine, so on an average I will be able to sell a laptop equal to the average of the previous sales which I have done in my last example, which I have discussed in last class, if you remember. So first of all, you have to build a null hypothesis and alternate hypothesis for any kind of a situation. And then you have to decide a label of significance. It can be anything. It depends upon us basically. Like we have used like a 1% or maybe a 5% or maybe a 10% that we are going to assume. So this is what, just give me a moment, guys. Okay, fine, guys. So basically we try to decide like what is the label of significance. That is completely fine. Now after deciding a label of significance in terms of hypothesis testing, so we always try to find out that which kind of a test will be a most suitable test for my for my data set or for my samples. And in this way, so there are a different kind of a test which has been developed and derived basically based on the like a different kind of a statistical significance. So those kind of a test is called as a Z test or a T test, or maybe I can say chi-squared test, or maybe I can say that, okay, so like it could be an ANOVA test. So these are the things which we are supposed to finalize. Now these kind of a test you will be able to finalize based on some of the facts which will be given about a data set. So which we'll try to cover for sure. So when you are supposed to do a jet test, or maybe a t-test, or maybe a chi-square test, and we'll see the example as well. So don't worry about that. So this is something that we are supposed to do. So first of all, build your null and alternate. Second one is decide your level of significance. The third one is to try to pick up a test. So what kind of a test that you are going to do to prove or disapprove this null and alternate hypothesis at any point of a time. So fine guys, let's try to understand these things. So let's try to do some kind of mathematical operations, I would say. So here, what we will try to do is, so we will try to solve some problem, right? So I think it's time to it's time. So we should start solving some kind of problem. So let's try to consider this question over here. This question over here based on the things that we have learned. So there is a manufacturer. There is a manufacturer of a printer cartridge. So I think we all are aware about the cartridge, right? So color, I would say. So there is a manufacturer who tried to manufacture, who is manufacturing, I would say, a printer cartridge, and claim, he is trying to make a claim that, okay, so a cartridge that he has manufactured, so with that you will be able to print, or you will be able to print a paper on an average at least 500 pages. So there is a cartridge manufacturer for a printer, and he is trying to claim that whatever cartridge he is going to provide you, so whatever cartridge he is going to provide you, basically, so with that cartridge, on an average, you will be able to print, you will be able to print how many pages? 500 pages, and that to a minimum 500 pages you will be able to print, or at least 500 pages you will be able to print for sure. Now, so suppose if I'll go to his factory, and then if I have to test this claim, that whether this person is trying to claim something is correct or it's a incorrect. Suppose this is what I'm supposed to do. So means I have to test that, okay, fine. So on an average, so it is able to print. So on an average, it is able to print a 500 pages or not, at least 500 pages or not. More than that, it's completely fine. But at least 500 pages, it is able to print or not. And then I'm planning to buy his. Then I'm planning to buy his cartridge, because I'm a wholesale, I'm a wholesale buyer, basically. So I have to decide that whether I should buy these things from him or not. And to decide this particular factor, so unless and until I'm not able to check his claim, so for sure I can't purchase. I will have to check a claim, whatever claim that they have made. So to perform this particular operation, so maybe we can try to, maybe what we can do is, so we can try to perform some kind of a testing. So maybe what we can do is, so we can try to collect a sample, because he is having so many printers, he is having millions of printer, he is having millions of cartridges. So what we will try to do is, so we will try to select a sample from maybe a different printer, because we have to prove over here that, okay, so whatever claim of the cartridge that you have made is correct or not. So what I will do is, I will go to 100 different printers, and then I will try to select a sample, I would say. So I will try to select maybe 100 different printer, and then I will try to test it by printing maybe 500 pages in all the 100 printers. So the printing capacity of a sample we are able to find out is equal to 490. So suppose if I have tested these things on 100 printer, I'm trying to test this claim. Now the output wise, it is, so when I have tested, so claim is this much, but when I have tested with 100 printers, so it is telling me that no, so it's a 490, I would say. So 490, and with the standard deviations of 30. So a standard deviation is equal to 30 that we are able to get. printing. So basically, like in terms of printing pages, means somewhere I am able to find out that, okay, fine. So on average 490 plus 30 and minus 30. So in between this range, all the printers are giving me some kind of output. Now, so I have to take a decision that, okay, so whether I should buy this printer, whether I should buy this cartridge from this manufacturer, or I should not buy this cartridge from this particular manufacturer. This is the kind of a decision which I'm supposed to make. So I think problem statement is very much clear. So there is a manufacturer who manufactures a 500 cartridge, there is a manufacturer who tried to manufacture a cartridge, I would say, for printers. Now, so he's claiming that every cartridge will be able to give you a print of 500 pages. What I have done is I have selected 100 different printers, and when I have tested it, so on an average, every printer was able to give me like a 490 plus minus 30. 30 is nothing but a standard deviation which has been given, I would say. So it's completely fine. So I have to make a decision that whether I should purchase this cartridge from this manufacturer in a wholesale, or I should not purchase, whether I should invest my money or I should not invest money. By considering a fact that, okay, fine, so 5% of margin I can accommodate. So even if it is like whatever this person has claimed, even if it is incorrect by 5%, right, it's completely fine. But if this person is incorrect by 10% or 15% or 20%, no, I will not buy it. So till 5%, yes, it's fine. I can. So if whatever output, whatever result that person is trying to claim, so if it is equal to like a, if like a, it's like a lesser than 5%, then in that case, it's completely fine. But if it's greater than a 5%, in that case, it's not fine for me, basically. And based on that, I will be able to make a decision. So I have to make a decision that, okay, so whether I should buy a cartridge from this particular manufacturer, I should not buy a cartridge from this particular manufacturer. So let's try to understand it one by one, right? So here, if I'll talk about population average means a claim. So printer, like this cartridge manufacturer is claiming that 500 pages per cartridge or per printer I will be able to give you. So I can say that, okay, fine. So on an average, so this is the claim that, okay, fine. So 500 pages it will be able to consider. Now, if I'll talk about a sample mean, right? Sample mean means I have selected 100 samples, 100 printers I have selected and then tested it. So sample mean X bar, mu is nothing but it's a population mean. X bar is nothing but it's a sample mean. So it's a 490. And I can say like a sample standard deviation is nothing but 30. So plus minus 30, I'm able to find it. I think we all understand a meaning of like I would say standard deviations. So I'm not going to discuss again. I think we have discussed these things in a last class itself. Now, significance label. So significance label I have considered as, let's suppose, 5%. So I said that, okay, fine. So like even if this person is wrong by 5%, I will accept it. I will buy. But if he is more than 5% on top of his claim, so in that case, I will not buy. So fine. Significance label or alpha, I can say, is nothing but it's a 5%. So again, we have decided that. And then if I'll talk about sample size, how many sample on which we have tested these things. So we have tested actually on 100 samples, which is already given inside your like example, inside your question. So you have to make a decision. This question is all about decision, that you will buy or you will not buy. So I can say that, okay, fine. So my null hypothesis is I will buy a cartridge from here. And my alternate hypothesis is nothing but I will not try to buy. So null and alternate nothing but just a statement. It's just a contextual statement with respect to a problem statement. That, okay, fine. So if this is one thing, I will just try to make an assumption and then I will try to prove it or disapprove it. If I'm able to prove it, prove my alternate assumptions, in that case, my actual assumption is incorrect. If I'm not able to prove it, then in that case, my actual assumption is correct. So fine, not an issue. So here you will be able to find out that, okay, so we have like a null hypothesis and we have a alternate hypothesis, and this is something that is already given. So population mean is given, sample mean is given, like a sample standard deviation is given, significance label is given, 5%. So till 5% of error means till 5% of type 1 error, because alpha is nothing but probability of getting a type 1 error as well. I think this is what we have discussed. So till 5%, yes, I can plus minus margin
I will be able to accommodate. And like a sample size was nothing but like 100. Okay. So first of all, we have to decide. So let's try to go ahead with a one by one procedure wise. So first of all, I have to decide that whether I'm trying to perform a one tail test or whether I'm trying to perform a two tail test. I have to decide that. So what was the claim? A claim was that this one, every cartridge will be able to print at least 500. At least 500 means 500 for sure it will print, but it can go beyond as well. So my null hypothesis says that it should always be greater than or equal to 500, I would say, a printing, average printing. This was my null hypothesis. This is what I'm trying to approve or disapprove, basically. So it's completely fine. So, and again, so if it is lesser than 500, if it is lesser than 500, then only it will fall under alternate hypothesis. So I can very clearly say that, okay, so we are just supposed to check for what? Just for one direction. So just for one direction, we are supposed to test. So this is basically a one tail test or left hand side test, I can say. In this particular situation, so I'm trying to perform a left hand side test or one tail test in this particular way. Now, so if we know almost everything about a population, like a standard deviations, or I would say like either standard deviation, or maybe like if I know the mean of the population, so in that case I'm supposed to do a Z statistics, or I'm supposed to perform a Z test. So if only in one condition, so if I know about the population mean, so in that case I can try to consider maybe a Z statistics. Okay, that is completely fine. We have a table for that. As of now, like you can see that, okay, fine. So population mean is given over here. So it's which is 500. So it's not an issue. So I will try to perform a Z statistical test, I would say. Now, whenever we try to perform a Z test in this particular place, so we always try to find out what? We always try to find out a standard error, which we can denote that as a SE. So a standard error. So let me try to take some different page. So a standard error, or I can say SE, is nothing but, I would say, so sample standard deviations divided by sample size into, I can say, label of significance. Okay, so fine guys, not an issue, I would say. So let's try to perform this particular operations, I would say. So what we will try to do is, so we will try to, okay, sorry. So here it's not a level of significance. It's basically like a 0.5. Okay. So fine. So first of all, we will try to find out that what is an error, what is a standard error that we have. So if we have to prove this one, or if we have to disapprove this one, so first of all, I will try to find out what? I will try to find out a standard error. So what is a sample standard deviation? So sample standard deviation is nothing but, so we have written over here, which is equal to 30. So it's completely fine. Sample standard deviation is equal to 30 divided by a sample size. What is the sample size that has been given? Sample size given as 100. So it's completely fine. It's basically 100 into 0.5. If I will try to perform this kind of operation, so it's completely fine, I would say. So it will be like sorry, it will be in this way. So standard error is nothing but standard error is nothing but n divided by, no, standard deviation divided by root of n. Yeah, this will be the actual formula. Now, what is the meaning of that? So this is nothing but standard deviations of a sample divided by root of n, and this is nothing but, I would say, a sample size. Okay, so sample is given as a 30. So standard deviation for the sample, standard deviation of the sample is given as 30 divided by a sample size, which is nothing but 100. So 30 by 10 is equal to 3. So standard error wise, you will be able to find out this is equal to 3. So this is the actual formula, guys. So a sample divided by root of n. Root of n is nothing but, root of n is nothing but, so basically it's a total number of the sample that you will be able to calculate. So first of all, what we used to do is, so we always try to calculate basically a standard error. So we always try to consider a standard error. Now, so we will try to perform a Z. So if you remember, so this is something that we have discussed in our, I would say, like last class. So suppose if I have a data and then if I have to convert those data on a Z scale, or maybe if I have to normalize a data. So in that case, I always try to like do in this way. So data minus mu divided by like a sigma. So divided by, I can say, like a standard deviations. So this is what we used to do. Now in terms of testing, so whenever you're trying to do a hypothesis testing, so almost similar kind of things that you will be able to find out. So Z test says that, so it's nothing but you can try to find out Z basically of the data, sample minus sample mean, I would say, mean minus population mean divided by standard error. Sample mean minus population mean divided by standard error. I think we know the sample mean. So we have taken 100 sample and on an average mean was 490. So I can say that 490 minus what is a population mean. So population average or claim, what was the claim? So it was 500 basically. So 490 minus 500 divided by standard error. So what is the standard error? So basically standard error is equal to 3. So 490 minus 500, I can clearly say that, okay, so this is nothing but minus of 10 divided by 3 is equal to minus of 3.33. So this is a Z test that you are able to find out. This is a Z test that you are able to find out. Now, what is the meaning of it? It's a very simple calculation that we have done, but why we are doing this? That's a major question that we have, that why we are trying to perform this kind of a Z testing over here. So what we used to do is, so whenever someone will give you some kind of hypothesis testing, so you try to find out a Z test, or you try to find out a T test, or you try to find out a chi-square test or ANOVA test for one tail or two tail. And then you try to match these things with what? With a Z table. Now, after that, you try to make a decision. So it's completely fine, not an issue. So we are trying to perform a Z test, and Z test is nothing but, so sample mean minus population mean divided by standard error. And a standard error is nothing but a standard deviation, sample standard deviation divided by sample mean. So divided by sample size, I would say. So root of sample size, I would say. So fine. So we are able to perform a Z test, and Z test value is giving me minus 3.33. So this is what I will be, I'm able to get it from here. Now, how I will be able to make a decision that whether I should buy this printer or not, because this is the decision which I have to make. This is a decision which I have to make. And whenever I'm going to make a decision, so whenever I'm going to make a decision, so if it is falling under alternate hypothesis, in that case, I can reject it, means I will not buy. If this is correct, now when this will be correct, so if my data will come under a significance level of a 5%, if it is coming under this one, so in that case I can say that okay, fine, so just accept a alternate hypothesis, reject a null. So reject a null in this particular test. So fine, not an issue. So if you will try to find out a critical value. So what we have to do in this particular case. So let's try to understand. So we have given a significance label is equal to 5%, means alpha is equal to 5%, means critical region is 5%. I would say critical region was, so let's suppose this entire area is 100%. So if something is falling in this region, if something is falling in this particular region, so I can say that, okay, fine. So that critical region is basically 5%. So Z value we are able to find out. That is completely fine. Z value we are able to find out. Now, if we are able to find out a Z value, now, so what we have to do is, so we are supposed to find out that, okay, so what is a Z of a 5%? Means what is Z of alpha? Means what is Z of 0.05? I have to find out this. I have to find out this particular one, basically, that what is a Z of 0.05%, basically. If I'm able to find out Z of 0.05 or Z of 5%, so in that case, I will be able to reject or I will be able to accept based on certain condition. I'll talk about that. So how I will be able to find out a Z of 0.05? Even last time we were taking alpha by 2, right? 5 like 0.05 by 2 or maybe 0.10 by 2. This is what we have taken. So how I will be able to find out a Z of 0.05? Now to do that, what I can try to perform is I can try to share my screen. Just give me a moment. Okay. So Z table, I will try to search. Again, it's the same old table I think we were referring to, right? So Z table, I will try to open up a Z table from anywhere. And Z of 0.05 I have to find out. So, and that too for the left hand side, because it's a negative value. It's a negative test that we are trying to perform. It's a negative test that we are trying to do in this particular case, I would say. So it's completely fine. So if you will start looking for the values, so somewhere you will be able to find out a value close to okay, so somewhere you will be able to find out a value close to, I would say, a 0.5. So if you will just start looking into the body of this Z table, right? So if you will start looking at body of this Z table, so here you will be able to find out that there are some values which I'm able to get, which is almost like close to 0.5, right? So which value is close to 0.5? I can say that this value is the closest one. 0.049 is a closest one, right? It's a closest one. Maybe I can pick this one as well. I can try to pick this one as well. It's completely fine. Now, so if I have to find out actual Z value. So Z value was what? In the last phase, in the last class, so we were trying to find out Z value. Z value was what? Z value was basically a normalized value. So we are able to find out a Z value. Our Z value is what? Minus 3.33. Means normalized value is 3.33. Now that value is going to occupy how much of area if we have to find out. Then we always try to look into this way, like a row and column fashion. But here, so we are talking about a significance means. So I'm talking about like whether it is going to occupy a 0.5% area or not. So I'm talking about an area as of now. So I have to look into the area part in this time. So basically I will try to like look into this particular area part and you will be able to find out that, okay, fine. So if I'll just try to pick maybe one value, right? I'll just try to pick maybe this value. So now this value is what? So this value is a combination of, I can say this and this. So I can say that, okay, fine. So it's nothing but 1.60 plus, so summation of 0.04. So it's nothing but 1.64. I will try to look into this value and I will try to look into this value. So 50%, this 0.5%, so 5% or 0.05 area will be occupied by which Z value? So it will be occupied by minus 1.64, means what normalized value? So normalized value is minus 1.64. So fine, we are able to find out a Z for 5% from the table itself. This is how we were able to find out a Z of something even last time. So when we said that, okay, fine, 95% confidence, 95% confidence, or 90% confidence, this is what we have discussed in last class. I told you that in next class, I will be talking about that. So this is what I was talking about. This is how we try to do, if we know the area, if we know the percentage. So based on that, so we try to find out the Z values or normalized value. We try to find out all the time. So it's completely fine, guys, not an issue. So this for the 5% significance, again, you will be able to remember it, because every time for the 5%, you are going to get this data as well. Every time. For the 10%, for 99%, you will be able to get a very constant data. So you're not supposed to worry about that. But yes, this is how you will be able to find out. At the same point of time, you're not supposed to remember anything. You should know that, okay, fine, so how I can find out the values. So it's completely fine, guys, I would say. So here, so this Z for 5% is 1 minus of 1.64. Okay. So this part is done. Now I have to make a decision. Let me share my another screen. Okay. So here Z of 0.05 is what? Negative of 1.64. What is a Z which I'm able to find out? I'm able to find out minus of 3.33. So I have done the testing basically, and my test says that Z is equal to this one. I have done this testing based on the significance label, and my Z table says that it should be 1.64. Now I have a very simple requirement. Either I have to accept a null hypothesis or I have to reject a null hypothesis. This is the only thing which I have to do. Either I will accept it, either I will reject it. So based on the given things, so I'm able to find out a test, as well as I'm able to find out a Z value based on the significance level. Both the places we are trying to find out a Z value itself, I would say. So here we can see that. Here we can see very clearly that Z of test, just try to focus here just for now. So is lesser than, so this one is lesser than minus 3.33 is obviously lesser than mathematically, right? Then Z of 0.05. So whatever testing which I have done on top of my data, whatever Z I was able to find out based on my data, the data which has been given, population sample and all those data. So that was giving me minus 3.33, and significance level was given us as a 5% is given. So 0.05 in actuals. So testing result from the data is lesser than the table data that we are able to get for that particular significance. That means that I can say, so let me try to take a new page. So Z test is minus 3.33 and Z of 0.05. Z of 0.05 is 1.64. Now, so Z test I can say is lesser than Z of 0.05, which we have calculated from a table, basically. So if I will try to draw this normal distribution curve, because Z always try to find out itself on a normal distribution curve itself. Okay. So if I'm talking about this normal distribution curve, if this mu is equal to 0, if I'm going to consider, so here in this particular place, so maybe I will be able to find out a negative of 1.64 in this particular place, but I will be able to find out maybe a negative of, so negative of what? So negative of minus 3.33 in this particular place. Now, what is a reason which I have decided? I have decided that if it falls under 5%, we have decided that if it falls under 5%, in that case, I will reject it. Means, so if there is a 5% chance that it is going to fail, I will try to reject it, right? So this is my 5% one. This is what I have figured out from the Z table. So this is the area, this is the rejection area, this is the rejection region, I can say. So you can very clearly see that my value, which I'm able to find out from the Z test, is lying inside this region, inside this area. So very clearly, you will be able to see very clearly that this is my rejection area. So if something falls under this area, I will reject I will reject the null hypothesis. So here you will be able to find out that your Z test value is giving you minus 3.33, and it means that our test value lies in where our test value means our 3.33, our Z test value lies within a rejection region. Thus, what we can do is, so we can try to reject a null hypothesis. So null hypothesis is not correct, and we will try to accept a alternate hypothesis. Now, what was my null hypothesis? My null hypothesis was buy. I will reject it. I will not buy this one because I was assuming that if there is a discrepancy or if there is an error of 5%, I will buy it. But more than that, I can't afford. Basically, I am not going to buy it, right? So here, this is what I'm able to find out just by doing this Z test. Z test is very simple. Everything will be given you about data. So like a sample mean was given, like a population mean was given, a standard deviations for the sample was given, a number of the sample was given, and significance label was given. And based on that, you are either supposed to select it or you are either supposed to reject it. So in my cases, if I'm planning to buy a cartridge from this particular manufacturer, no, I will not go and I will not buy, because it is not trying to fulfill a significance label, I would say. So whatever like a data, whatever like a result which I'm able to get, so it's falling inside a rejection region. It's falling inside a rejection region. Minus 3.33 is falling inside the 5%, I would say. And in that case, I will clearly reject my null hypothesis. It's a very simple concept that we are trying to implement in this particular place. So it will always help me out to make a decision. So suppose if some facts and figures is given to you, and if I have to make a decision, business decision, that whether I should do it or whether I should not do it. So yes, I will try to perform this hypothesis testing, and then in that way, yes, I will be able to like get some kind of a statistical result. And this is what we do even in a machine learning, I would say. So fine, this is guys it from my side for today. So tomorrow probably I will talk about back-to-back just a mathematical formula, not a mathematical formula. So we'll try to look for the solution. So we'll try to discuss many question and answer back-to-back, one by one, and we'll try to find out that okay, fine. So what and all new things we can explore. So with that, guys, this is it from today's class. So those who have a question, so I think I can take some of question from your side. Yeah, so go ahead with your question. I think a couple of questions I can consider.
I was asking whenever we are making decisions, we will take it under the null hypothesis, right? The statement we are making the decision.
See, what happens is, so again, I told you that it's a contextual, right? Suppose I have made a null hypothesis as I'm not going to buy. Suppose if I have made a null hypothesis that, okay, fine, I'm not going to buy. Alternate is as a buy, right? Possible, right?
Yeah.
So again, basically, in an alternative way, we will try to fall under the same thing, right? In an alternative way, we are supposed to like reject one and accept one, right? So suppose if I'm asking you that what is the possibility that you are not going to buy? This time I have asked that, okay, fine. So what is the possibility that you are going to buy, right? What if I ask you, what is the possibility that you are not going to buy with the 5% significance or 95% significance, right?
Yes,
so can I say that I'm trying to ask the same question in a different way?
Yes,
So it's basically a contextual one, and we decide based on our like a situation. Basically, there is no rules that you are supposed to always consider. So in most of the cases, you will be able to observe that. So based on the question, so people try to build a hypothesis, null and alternate.
Yeah, one
But
more
it's
thing. The level of significance which we are choosing, is this the p-value we used to here that we used to choose for
yes, yeah. So level of significance defines a probability values as well, or area, you can say. So level of significance alpha is nothing but a probability of making a type 1 error. Now, what is a type 1 error? So type 1 error is nothing but, so when your null hypothesis is true, but still you have rejected it.
rejected.
Right? So that is called as our label of significance, I would say, alpha values.
And how do we choose it? For example, if we have choose the 10% of
We
the
don't choose it actually. So we don't choose it. We always assume it. So we don't choose it. So like people will ask you that, okay, fine. So for 5% significance, can you please test it? For 10% significance, can you please test it? And for 1% significance, can you please test it? Or for 20%, right?
it's basically
So
a margin error margin.
error rate, I would say. It's an error rate, right? So for 5% error rate, so what will be like a value that you will be able to get? It's an error rate. Generally, we write decide. Okay.
Okay, thank you.
Hello? So this is Abhishek.
Yeah. Go ahead. Say.
What is you have written one standard error. So can you tell
Yeah.
me, I understood by the formula, but why it is used and what is the significance of it?
So standard deviations we were using, right? So I think in the data statistics, so data minus mu divided by standard deviation. This is what we have used, right?
Yes,
You
sir.
remember?
Yeah.
Last. Okay. So here basically we don't have a data value. So there you will be able to find out that data was given to you, right? 10, 20, 1500 and all those things like last time, right?
Yes,
So data was given to you. So you were trying to normalize a data. How you were trying to normalize the data? So every
X
time
minus
data
mean by
minus divided by standard deviations, right?
yeah.
But
Yeah.
here, if I have to normalize my entire, I would say, like my entire mean, because sample mean is given to you, right? That is my data. Sample mean is given to me and population mean is given to me. If I have to normalize my sample mean, so in that case, what I will have to do? So I can't try to divide these things by the standard deviations in this case, right? So again, so there is a very minor difference in between. You will be able to find out. Standard error is nothing but like a standard deviation divided by total root of total number of the data set. So what we used to do is, so we always try to consider in a denominator a standard error instead of using a direct standard deviation, which is nothing but so average error, you can say. So in a like a layman way, right? You can say that, okay, fine. So average deviations we used to take, although it's not an average, like a s by root of n we are trying to do, but still you can, in a layman way, you can say that, okay, fine. So we are trying to divide these things by the, because we are trying to take a mean of the sample. So even in this case, so we are trying to take a mean of almost a mean of the standard deviations. Although this statement is not like a official statement, but still, this is how you can consider.
Oh,
Yeah.
okay. So one more thing, when you are adding in the Z table, when you are adding 1.60 by 0.4, so
Yeah.
0.4 is a positive value, correct? 0.04.
No, actually, we are trying to look into which table? A left table.
Okay.
There are two tables, right? One is a left table, one is a right table. Agree?
Yeah.
So in the left table, so whenever you are trying to add this like a first column and a first row, it should always be negative. Okay. In the right table, it will be positive. That's the reason. So we have a right and we have a left.
Okay. Okay. Understood. Thank you.
Yeah.
Sid,
Yeah. Go
we were
ahead.
speaking about the beta, right?
Okay.
So
Beta. Yeah.
beta is actually 1 minus alpha.
No, beta is not actually 1 minus alpha, I would say. So I never mentioned that beta is equal to 1 minus alpha. It never happens, I would say.
I'm just saying, because beta is 1 minus alpha. And if
No,
you look
no,
at
no,
the
no.
confusion matrix, your beta will
No.
be your precision. So beta will be your type, your true positive. Right?
Power of test, I would say, or maybe a type like in this case. So basically beta is nothing but a type 2 error. Type 2 error is what? So type 2, I'll talk about precision recall. So what is the precision? What is a recall? So I will be talking about that. But as of now, I can't make a statement that beta is 1 minus alpha, right? 1 minus alpha is basically like confidence. So 1 minus alpha is called as a confidence. Confidence is not equal to beta. Okay. So beta is basically a type 2 error, or in other way, you can say that probability of rejecting a null so probability of rejecting a null hypothesis when alternate hypothesis is true. Rejecting a null hypothesis when alternate, or maybe you can say that it's a false negative value, but I can't say that beta is equal to 1 minus alpha. No.
Yeah, so because the type 2 error is your false negative. So it's basically like you are telling a pregnant woman that she's not pregnant, basically.
So woman is not pregnant, and I'm saying that woman is pregnant. This is the condition. woman is, let's suppose, not pregnant, right? There is two conditions, pregnant or not pregnant, right?
Yeah, so the woman is
not
pregnant and I'm
pregnant.
saying she's not pregnant.
No. That is a different situation. So woman is, woman is not pregnant and you are, so doctor has checked and doctor is saying that, okay, fine, woman is pregnant.
Okay.
If, so suppose if woman is pregnant and if doctor is saying that no, woman is not pregnant. So let's just tell me one thing. So which condition will be more critical? If woman is pregnant and doctor said that after testing, doctor said that woman is not pregnant. So for condition one, right? Pregnant, doctor said that no, not pregnant. Or second condition is not pregnant and doctor said that pregnant. Which will be more critical?
I mean, if she's pregnant and you say
Yes.
she's not pregnant,
Yeah.
it depends. Okay, so let's say, for example, let me rephrase it so some people will understand. So if I'm talking about the type 1 error, which is my false positive, right?
Yes.
I'm actually talking about the alpha or recall or 1 minus specificity, which is actually saying I'm telling a man that he's pregnant.
Okay.
So that would be my false positive. And then my false negative is when I'm telling a pregnant woman that she's not pregnant, which is actually much worse because it's like you have cancer and I'm saying you don't have cancer.
Yeah, that is called as a false positive.
Yeah.
You have a concern basically, right? And I'm saying that no, you don't have a concern, right? So you have an issue, you have some kind of an issue, right? But I'm saying that no, you don't have an issue. It means that I'm not willing to solve your issue. Agree? Right?
Yeah, you're
So
right.
that is a much severe one, whereas second condition is you don't have an issue, right? But still I'm saying that no, you have an issue. And in that case, maybe I'll try to solve it, right? So you don't have an issue or you have not done something, right? You have like not done something and maybe I'm trying to say that, okay, fine. So no, like not in this way. So yeah, you have an issue and I'm saying that, okay, fine. You don't have an issue and I'm saying that no, you have an issue and let me solve it, right? So I think this issue is a less severe issue as compared to a fact that you have an issue and you're saying that no, I'm saying that no, you don't have an issue. Or I can say in terms of a pregnant woman. So if woman is pregnant, doctor said that no, so you're not pregnant. So can I say that in this case, doctor will not recommend a treatment, right? But can I say that pregnant woman needs a treatment? Agree? So that is basically a more severe one. If woman is, let's suppose, not pregnant and doctor has given some kind of a prescription, I can say that, okay, fine, so doctor has written some kind of a test. Let's understand in this way. So if woman is pregnant, a woman is not pregnant and doctor has not written any kind of a test, I think that is a severe issue as compared to if woman is not pregnant and then doctor has written some kind of a test. Making sense? Yeah. Just try to understand in this way. So again, like it's a confusion matrix, right? So it always confuses people. It is completely fine. You can maybe try to correlate and understand in this way. So type 1 is always a severe issue as compared to a type 2 error. Again, it depends upon a scenario how we are going to build it. But yeah, type 1 is called as a false positive when my null is true, but I'm trying to reject a null. Right? When there is a fact, but I'm not trying to accept it. Right?
Okay.
So that is called as a alpha. Beta is nothing but like a power of test, or I can say rejecting a null hypothesis. When I would say not rejecting a null hypothesis when null hypothesis is false. Yeah. Sorry. True. No. False. Again, my bad. Okay, guys, so fine, just try to revise. It's a confusion matrix, so yeah, it will always confuse you. Again, it's a contextual thing, so if you will go through a 4 to 5 scenario, and again, even in next class, so I'll try to consider those things and we'll try to solve it. So fine, till then, so yeah, so take care and enjoy your weekend. With that, thank you so much and have a great day ahead and night.